You came across this question in your chemistry exam. How will you solve it? It is very easy. Now let's solve together. The question says, a chemical reaction occurs at 298 K. That K there simply means Kelvin. So this should be pronounced as 298 Kelvin. All right, let's progress. The enthalpy change is this value. And how is this value pronounced? It is minus 120 kJ. kJ simply means kilojoules, slash there means per. So this is kilojoule per moles. So this is the enthalpy change. Relax. I'm going to explain everything you need to know to solve questions on these aspects. At the end of solving this question, I'm going to give you your own practice question so you solve to master how to solve questions under this topic. As I solve the question, I will tell us the topic to which this question is from in chemistry. All right. And the entropy change is this value, which is minus 200 joules. Now it's not kilojoule. Now it's not what? Joules. J means joules per moles Kelvin. Are you there? This K also means Kelvin. Relax. The question is very easy. It is not difficult at all. Now the question now says at the end, what is the Gibbs energy in brackets standard? All right, so how do we solve this question? Before we solve this question, we have to know the topic to which this question is from, because I saw so many parameters, so many terminologies in this question, and me seeing that, I already know the topic to which this question is from. And from the look of things, this question on the board is from a very key aspect in chemistry called thermodynamics. And it is very, very easy. Thermodynamics, but specifically under a key aspect called spontaneity of a chemical reaction. I'm going to explain all these. So you just pay close attention to how I'll be solving the question. You can see I've said that the question is on the broad topic thermodynamics in chemistry, but specifically on a very key aspect in chemistry called spontaneity of a chemical reaction. All right, guys, moving further. Me saying that this question is under this aspect specifically called spontaneity of a chemical reaction, there is a terminology we have to be aware of, and that is what we call spontaneous. All right, in chemistry we have reactions that are spontaneous, and I'll be explaining to you what I mean by that. I just said that we have a reaction that is spontaneous. So first of all, we have to know what spontaneous reactions are. Now, spontaneous reactions are reactions that occurs under a given set of conditions. In simple terms, a spontaneous reaction is a reaction that can occur on its own. Please listen very well. Now, in the topic thermodynamics, specifically spontaneity of a chemical reaction, these given sets of conditions are three. What did I say? They are three. They are regarded, the first one is called enthalpy, the next one is called entropy. All right, please listen very well. Entropy, and the last condition that tells us if a reaction will be spontaneous or not is what we call Gibbs energy. What did I say? It's what we call what? Gibbs energy, or if we don't call it Gibbs energy, we simply call it free energy. Are you there? Gibbs energy or free energy. All right, guys, so moving further, all of these terminologies they have their own respective definitions, all right? But in the course of this class lesson, my explanation will be based on solving this question on the board. This topic has so many concepts, and in more video lessons, I'm going to talk about them. Please ensure you watch this video till the end, because at the end of solving this question, I'm going to give you your own practice question to solve to master this aspect properly. So moving further, what does enthalpy means? Now, enthalpy is simply the heat content of a reaction. What did I say? Enthalpy is the heat content of a reaction. Looking at the word heat, what actually starts it? It is H. So this is why you must note this. Enthalpy has a symbol to which it is noted, and the symbol is H. Please listen very well. Listen very well. Whereby, okay, so let us progress. As we are having enthalpy, so we are having what we call enthalpy change. You know, in science, whenever we hear change, this symbol will come to our mind. And I just said enthalpy change. Enthalpy change. So actually, the symbol for enthalpy change is delta H. Please note it. As we are having enthalpy to be H, enthalpy change will be what? Delta H. Remember I said that I'm not going to deeply explain all the concepts, all right? Because I want to solve this question. So my explanation will be based on solving this question. That is why you should not miss out on my next video upload, where I'll be explaining more concepts under this aspect. All right, guys. So moving further, let's get into what entropy is. Now, what is entropy? Entropy is simply the degree of disorderliness in a reaction. The degree of what? Disorderliness. Entropy is favored when a reaction is in a disordered state. And you know, when something will be in a disordered state, that reaction most likely will be gaseous, because gases are the state of matter that basically move in a zigzag direction, zigzag motion. So my point here is this. Just understand here that, remember I said I'm not going to deeply explain them because I want to solve this question on the board. And all my explanation in the course of this class lesson will help us solve this question. So pay close attention. It is very, very important. So then, moving further, as we are having entropy to be S, you know, I told you guys that entropy is symbolized as S. So this condition that also tells us if a reaction will be spontaneous or not has its own change format, all right? So change in entropy symbol will now be delta S. You can see the way I pronounce it, delta S. So this change is also same as delta. Are you there? In science, this is delta H, delta S. Are you following me? So all these must be noted. All of them listed here, they are conditions that determines if a reaction will be spontaneous or not. Relax. All these are very, very easy. They are not difficult at all. So moving further, let's get to the last condition, which is one of the most important, that tells us if a reaction will be spontaneous or not. And it is called Gibbs energy. Gibbs energy is also regarded to be called free energy. So I can call it Gibbs energy or free energy. In some books, they put them together and call it Gibbs free energy. Are you there? But me, I'm telling you now that you can either call it Gibbs energy or free energy. You are saying the same thing. Are you there? All right. So moving further, what is Gibbs energy? Now listen. Gibbs energy or free energy in a chemical reaction is the energy available to do work. It's just like the normal definition for energy you are aware of. Are you there? That is what we call the Gibbs energy. Now, Gibbs energy is symbolized as this, delta G. Please, oh, you can see I did not write any form of G. I just said that Gibbs energy is what? Delta G. And note it. It is very, very important. So you can see that we've discussed all of the conditions that tells us if a reaction will be spontaneous or not, because all these I'm saying will help us solve this question. So you pay close attention. So you must ensure you watch this video till the end, because at the end of solving this question, I'll be giving you your own practice question so you solve and provide the answer in the comment section. All right, so let's get into more explanation on this aspect of thermodynamics. Note this, thermodynamics has various concepts and they are all very easy. But in the course of this class lesson, I'll be explaining just on spontaneity. Though I actually did not even go deep into each of them. I already have more videos on my channel that explains on them deeply. All right. The reason I'm just explaining this so that we can have the insight on how questions like this, I'll tell you how to know questions like this and how to solve questions like this whenever you see them. So you just pay close attention. All right, guys, moving further. Remember, I told you that all of these are conditions that tells us if a reaction will be spontaneous or not. Now, you must note this now. All of these conditions, they are regarded to be one terminology. And all these things here, they are simply called state functions. Please listen very well. They can ask you in your exam, list out the state functions in the topic thermodynamics or in the concept spontaneity of a chemical reaction. There are three important state functions, which include enthalpy, entropy, or Gibbs energy. But if we're talking about the change format, it includes delta H, which is enthalpy change, delta S, which is entropy change, and delta G, which is still Gibbs energy. So all of these are the state functions. I beg you, note it. Note it, they are all very easy and very important. All right, guys, you can see I've explained that all these are the state functions we have in the topic thermodynamics. Now, note this. This is where the class becomes more interesting, okay? Now, all of these state functions, three of them, they are related by a formula. Please listen very well. There is a formula that actually relates all of them together. And that formula is simply delta G is equal to delta H, all right, minus T delta S. Are you not seeing the formula? Please note this, they can ask you. In the topic spontaneity of the chemical reaction, which formula relates all the state functions together? This is the formula. You there? They are all very easy. And in the course of this class, I'll be explaining how to use the formula to solve questions that pertains to the formula. Are you there? Because it is not all questions under thermodynamics you can use this formula. That is why I said you should not miss out on my next video upload where I'll be talking about more concepts under this aspect. All right, so I will tell you the difference, how to know how to solve questions on a particular aspect, on another aspect. They're all very easy. They are not difficult at all. Now please listen very well. This is where the class becomes more interesting. Okay, now if you observe, I told you that Gibbs energy symbolized as delta G, because I've read the question already, and at the end of the question they said, what is the Gibbs energy? So they asked us for Gibbs energy. Note this, Gibbs energy can occur in two forms. Can occur in how many forms? Majorly under this aspect, two forms. We have the standard Gibbs energy and we have the non-standard Gibbs energy. Delta G, which is Gibbs energy, can occur in two conditions. We have the standard Gibbs energy and the non-standard Gibbs energy. For the standard, there are criteria to know that a particular question is asking you to get the standard free energy or standard Gibbs energy. But in this question, they made things easy for us. They just told us that, okay, the Gibbs energy you have to look for is standard Gibbs energy, because standard Gibbs energy is different from non-standard Gibbs energy. When Gibbs energy is standard, it occurs under some given set of conditions, all right? For Gibbs energy to be standard, the temperature should be at room temperature. And you know, room temperature is 25 degrees Celsius. So, please listen. One of the criteria to know that delta G is standard is when the temperature is in 25 degrees Celsius, that's like room temperature. Pressure is in 1 atm, 1 atmospheric pressure, and the concentration is 1 molar, 1 capital letter M. Please listen. So you can see here that there are various criteria, which are about 3 criteria, that tells us that delta G is in standard condition. One of them is temperature, the other is pressure, and lastly is concentration. Temperature must be in what value? Room temperature, which is about 25 degrees Celsius, and pressure should be in 1 atmospheric pressure, 1 atm, and concentration will be 1 molar, which basically stands for concentration. Please listen. I know you are wondering, the temperature given to us in this question is not, I know you have to say, okay, it's not what I just said that, okay, if delta G is standard, that means, since I told you guys that the temperature should be in room temperature, which is about 25 degrees Celsius, that means this is supposed to be, no, this can't be 25 degrees Celsius, because when we are solving, we must ensure that we convert that temperature. We don't want to see any temperature being expressed in degrees Celsius in most calculations in chemistry. So that is what we convert to Kelvin temperature. So how do we convert 25 degrees Celsius to Kelvin? Very easy. We simply say Kelvin is equal to degrees Celsius adds 273. So when you do that, what becomes this guy? So Kelvin will now be, what's the degree Celsius? That's 25, which is the normal. All right, for this one, 25 degrees Celsius plus what? 273, and that is 298 Kelvin. I believe you are following me. So that is why this question existed at 298 Kelvin. But you can see this question made it so easy for us because they said that the delta G, which is Gibbs energy or free energy we have to look for, is standard. So they just made things easy for us, no stress at all. Now, there's something I'm about telling us that is extremely very important. Whenever we hear standard Gibbs energy, that's what we are looking for. Anything standard at all, please. Your format of your formula will change. This is what will change. I know it is delta G, but since it is standard Gibbs energy, it will be delta G naught is equal to delta H naught minus T delta S naught. The T, which is temperature, does not have any, naught up. This thing is pronounced as naught. Now, why did I do it like this? I actually rewrote the formula because I saw that the Gibbs energy was in standard condition. If Gibbs energy was not in standard condition, then I will leave it like this. Do you understand? And actually, there is a specific formula which is different from this to solve questions for Gibbs energy when it's not in standard conditions, all right? And there's another way we know them. Please listen. The confirmation that we have to use this formula to solve is because of the parameters they gave to us in the question. If you observe, we said that a chemical reaction occurs at this temperature, that is T. Do you understand? So T is part of my formula, so then it's a sign that, oh, this formula is best, alright? The enthalpy change, wow, this is enthalpy change, delta H now. So they gave me enthalpy change, is also valued. And the entropy change, wow, you can see that it is a confirmation. Entropy change is this one as well. So it's a confirmation that you must use this formula to solve, but you must write the formula in the standard condition. The reason I'm doing this so that you understand what you are doing, not just writing. You get. So for standard condition, you put your not, and not. So then we are looking for delta G. Delta G will now be delta G naught, which is the standard Gibbs energy, will now be delta H. Alright, delta H naught, which is this, which is the enthalpy change, is minus 120 kilojoules per mole. So we have to be very careful, alright? So let's do this first. Minus 120 kilojoules per moles. Are you there? Minus T. T is temperature, right? So actually T delta S, they are together. But T delta S is like you saying temperature times this. So put them in a bracket. I don't want any stress. Are you there? So what's the T? Should I use 25 degrees Celsius or 298 Kelvin? 298, I beg you. Use 298 Kelvin. Don't ever use degree Celsius value to solve in most calculations in chemistry. Alright? So you can see we talk about the T. What delta S means times delta S. Now you must ensure something, alright? You must ensure that the units of your parameters are the same. If you observe, entropy change was joules per mole. Enthalpy change was kilojoules, so they're different. Ensure you convert this thing to minus 200 joules per mole to kilojoules per mole, meaning that let us now see this is the task we have. So what we do, we must convert this minus 200 joules to kilojoules. Listen very well. This mole and Kelvin still remains, alright? It's the joule part we are converting. Alright, just listen. So then what happens is this. We simply write minus 200 joules to kilojoules. How does this work? Alright, how do you convert minus 200 joules to kilojoules? So we already know here that, so you should know this conversion factor. Please note it. 1 kilojoules is equal to 1000 joules. Are you following? Please note it. Okay, here should be kilojoules, right? 1 kilojoule is equal to 1000 joules. So what we are converting to kilojoules. So here become X kilojoules is equal to minus 200 what? Joules. Please, are you following me? They are all very easy. They are not difficult at all. Because the kilojoule goes together, joules goes together. So then we cross multiply. So what become X kilojoule? Let's find a way to write it here. So X kilojoule will now be what? 1 times this divided by 1000. So 1 kilojoules times minus 200 joules is equal to 1000 joules. You understand what's happening now? So then let's divide. So minus 200, 1 times minus 200 is minus 200. So minus 200 divided by 1000, that is minus 0.2, alright? So X kilojoule will now be equal to minus 0.2. Meaning that, listen, this thing will have been minus 200 joules per mole Kelvin will now be minus 0.2 kilojoules per moles and Kelvin. Why? Now, in summary, for you to convert something from joules to kilojoule, divide by 1000, divide by 1000. Are you there? So what then happens? This delta S, this is the correct value you have to write. Not this one, no, because you can see that they are not in the same unit, but you must ensure that they are in the same unit. So then, that become minus 0.2 kilojoules slash moles per Kelvin, alright? So let's impute the parameter in our calculator carefully. So let's solve for the bracket, Bodman, solve for the bracket first. So it's going to be 298, alright, times minus 0.2, that is minus 59.6, alright. So delta G is now equal to minus 120 minus, I just removed the units, just leave that alone. Insofar you can see that we've ensured that we are in the same unit. Let's just leave the units and progress. Minus, what is inside this bracket? We've solved it to be, there's minus here, remember that to open, we've solved for the bracket already, so minus 59.6. Are you there? So guys, you can see what we've gotten after evaluating this bracket. So we've gotten minus 59.6. So moving further, delta G will now be what? Okay, you know when minus comes together, it gives us plus. Hope you know now. Minus times minus is plus. But what you do, just input everything into your calculator. So we have minus 120 minus 59.6. Input it correctly. You can see the final answer we got for this question is delta G will now be minus 60.4. Minus 60. You know this is energy, right? You know energy can be either expressed in joules or kilojoules. You know this is chemistry, and then a mole of a substance. That's why it's per mole. So if you check all the units, per mole. Alright, it must actually indicate that. Is in our representation initially. So listen very well. There is something I have to tell us very well. So if you observe, you can see that the unit of these two guys were in kilojoules. That is why this guy becomes in kilojoules per moles. Are you there? Please listen. And this is the answer to the question. So you go to your option and determine the answer. Is it the one with minus or plus? Please, you have to be careful. It is option A that is the answer to the question, because you can see that we had a negative answer. Okay guys, we are done solving. It's not just about solving. You have to be able to understand what you have solved. So let us interpret our answer. Please listen. This delta G we are looking at, called Gibbs energy, which I've explained for us. Gibbs energy can exist in two forms. Please listen. Gibbs energy can be positive, and Gibbs energy can also be negative. In the course of our calculation, we had our delta G, which is Gibbs energy, to be negative. Whenever Gibbs energy in a reaction is negative, it means that that reaction is hexagonic. Please listen. I just said something. When delta G in a reaction is negative, that reaction is hexagonic. I did not say the reaction is exothermic. No. Please listen. That's why you should watch other video lessons on my channel that explains on all of these things, alright? So please just pay attention. When delta G again is positive in a calculation, so when it's positive, that reaction is endagonic. You can see this one is endagonic for positive delta G and hexagonic for negative delta G. So for our answer from the interpretation now, since our answer gave us a negative answer, since we had a negative answer, delta G in this reaction will be what? Hexagonic. So in summary, the reaction is hexagonic based on the question given to us. Are you there? Now there's something very key I have to tell us also. To know if a reaction is spontaneous or not, it is determined majorly by the Gibbs energy. And just note this. When Gibbs energy is negative, it tells us that that reaction is spontaneous. So you can see that we had a negative answer for our delta G. So this reaction is what? Spontaneous. But when delta G, we have a positive answer for our delta G, it means that that reaction is non-spontaneous. Are you seeing the difference? So please pay close attention to all these things. They are very, very vital. Remember guys, I told you guys that there are further explanations on all of mostly enthalpy, entropy that we've not talked about. But in more video lessons, we're going to discuss about them. So you can see that whenever you see a practice question that relates three of them, this is the most likely formula to use. And I'll be giving you guys your own practice question. So in this case, I'm going to change this to, let's say, it was 120 before. Let's say to 180 kilojoules per mole. And here is now, let's say it is, let's take it higher, like 300 joules per mole. So you already know what to do. Since 300 much, I'm sure you convert to kilojoule before you solve, and then you provide the answer to the question and tell me if the reaction is endagonic or hexagonic, or if the reaction is spontaneous or non-spontaneous. Tell me the answer. You know it already. Follow instructions. Now also for this enthalpy, if enthalpy, you are seeing enthalpy change specifically. Remember I said that enthalpy is the heat content of the reaction, and heat has to do with temperature, right? So when this guy delta H is positive, that reaction is endothermic. But when it is negative, that reaction is exothermic. Heat is given off to the surrounding. Are you seeing the difference? I'm talking about enthalpy, but in more video lessons, we're going to talk more on them exhaustively. You can see the way we related three of them in questions, alright? And when we have to use a particular formula to solve another type of question under thermodynamics, we'll talk about that, alright? So that is for that on the course of this lesson. If you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons with your friends. Thanks for watching.